Hi, everybody. Welcome back to the Schuko Statistic lecturing series. And we are still in the unit Introduction to Probability. So from the video number 1 here, we talk about how to find the binomial coefficients here. And then we also discussed what is the generalized binomial coefficients. And we did 5 or 6 examples about it. So this video, we're going to talk about the 3 related theory to the binomial coefficients. Like I mentioned during the previous video, for this video, if you are only take the introduction statistics, you might be able to skip this video here because this video will just show you how to prove those equations. But if you are in the higher class and you are specifically, if you are in the mathematical statistics class, so you might want to go over this video and basically to show you how to use the binomial coefficients, the formula, and try to prove those formulas here, those 3 different formulas, and I'm going to show you how to prove it. And so let's go to the whiteboard and let's see how can we do that. So the first thing is here, all right? So we know, in general, we did the binomial coefficients, right? So we said x plus y to the nth power, right? So you can expand that. And so the coefficient, so when the n is small, you can use a Pascal triangle, but when n is large, the Pascal triangle is not reasonable neither, right? Because you need to write it down. So we know from the previous video, so the coefficient, if I have x to the n minus r and the y to the r's power, so if we want to find the coefficient for this ones here, so we know the coefficient is what? It's n to the what? N to the r's here, right? And so this is from our previous video. Then also from the lecture, number 2, we also learned the n to the r. The formula for the n to the r is equal to the n factorial, r factorial, and n minus r factorials, right? So that's how do we find the value of, if you said it's n equal to 10, r equal to 4, how do we find the total combination for the n take r's here? Okay, so now I'm going to use these 2, and let's take a look. The first one's here. Okay, so the first equation is here. This is like nr is equal to the n minus r. And so this one's here is kind of like intuitively is the truth, right? So in here, so basically you say here is one, if you have n positions here, right? So you have n positions here. Right, so if you want to take R, so like R could be here, could be here, could be here, could be here, right? So you want to calculate how many ways from the N you can take this R. It's kind of like an equivalent to how many ways from the N you can take it's not R's, right? So this is, we call this not R's here, right? So it's kind of like the intuitively it's true. So, but how do I prove it? Just like while I think we did one example in the lecture number 2, if you toss a coin 6 times, I want to find how many different ways you can get 2 heads, right? So in that one's here, so if you still remember, we said if you toss a coin 6 times, right? So n is equal to 6, how many you can get 2 heads, right? So the 2 heads here, so you can say this is 6 over 2. And 6 over 2, you get 2 heads is the same as you say, I get 4 tails, right? So that's why the 6 is equal to 6 over 4 so here. So intuitively, this equation is true. So how do I prove it, right? Okay, so here, let's take a look here. The reason I want to show this, because in the mathematical statistics, we do require some type of a proof, and for the some equations you will see in the later lectures. We're going to do this once a while, but not frequently, but you know, for some important equation, we're going to show you how to prove it. So n factorial from the lecture number 2, I know is n r factorial n minus r factorial, right? So this is from the lecture number 2. Okay, so now this is n minus r. Think about it, right? So it's just like you kind of treat this is like r, like I call it r stars, right? Okay, so now let's see here. So this will be by using the lecture number 2. So this is n factorial, r factorials, right? So here this is r factorial. So here you can write this is r star factorials, right? So this is n minus r factorial, or you can say this is what? This is r stars, right? Okay, so now in here, this is n minus r. So this is n minus r factorial, correct? So it's kind of like this one's here. If you use this new notation, so this is n minus r star, right? So try to match the lecture number 2. So this one is easy. So this is n factorial. So this is n minus r factorial. So n minus r. So n minus. So what is here? So this is going to cancel out the n's, right? So they have a positive r. So this is r factorial. Hey, match, right? So it's match what I have defined here, right? So that's why I prove it. So this is n to the r. Okay, so like I said, this one is pretty easy to prove it. Okay, so now let's take a look. How do I prove the next ones here? Next one, I need to prove n to the r is equal to n minus 1 to the r, then n minus 1 to the r minus 1. Oh boy. Okay, so how do I do it? Okay, so here is what we're going to use, what we learned for the binomial expansions, right? So instead of x plus y, I will say this is y plus 1 plus y to the nth power. All right, I can expand that. This is 1 plus y times 1 plus y to the n minus 1. That's right. Okay, now I can use the distributive properties, right? So I can use the distributive properties here. So this will give me 1 plus y to the n minus 1 plus y to the 1 plus y to the n minus 1, right? Okay, so this is a pretty, you know, so this is a pretty straight algebra, right? So now by the binomial expansions, right? So by the binomial expansions, we know for the coefficient for the YR, right? So because the X right now is 1, so I want to simplify. So the coefficient for the YR in the 1 plus y to the n. So what is the coefficients here? Is n to the r's power, right? That's what is the coefficient for the y. Now let's take a look, okay? So the coefficient of the YR, let's see here in this expansion, 1 plus y to the n minus 1, see here. So what is the coefficients here? Well, still the same, right? So it will be, because right now you only expand the what? You only expand the n minus 1 here. So what is the coefficient? Will be the n minus 1 to what? To the r's power, right? Remember? So here, that's what the formula we have. We have like we said x plus y to the nth power. This will be summation r from 0 to the n, x to the n minus r, y to the r's, right? So right now I let x equal to 1. So when y equal to y to the r's power, so it's equal to n minus 1, take the r's, right? Okay, so now let's take a look coefficient of YR in these terms here. Okay, so take a look here because, you know, because I have what? I have a y here, right? So in order to get the y to the r's power, I really need to, what type of powers here? So I really care is y to the what? R minus 1's exponents, right? Because y times r, the y minus 1 is r, right? So in here, so how do I get a y to the r minus 1? So this will be n minus 1, r minus 1 here. So that's why, because the coefficient of this one has to be, because the coefficient we expanded 1 plus y to the nth power has to be, you add these two terms, right? So that's why we prove here, we say, hey, the nr is equal to n minus 1 to the r plus n minus 1, the r minus 1, right? So by using the polynomial expansions here, binomial expansions, right? So now I'm just, to the simplified, I just let the x equal to 1 because I just want to care about what is the coefficient, you know, the coefficient of the y to the r's powers here. All right, so this proof is quite simple also, but it's very interesting. How do you use the binomial expansions and try to prove formulas here? All right, so now let's take a look at this one. This one is interesting, all right? Okay, so this one is a summation k equal to r equal to 0, mr n the k minus r, n plus n to the k. Okay, okay. Okay, so now let's take a look at this one here. I'm going to use the same concept, right? Okay, so let's say here y, 1 plus y to the m plus n's power. All right, so 1 plus y to the m plus n. So this one I can separate is 1 plus y to the m's power and the 1 plus y to the n's power, correct? Okay, so now we're going to use the coefficient concept again, right? Okay, so the coefficient of the y to the, let's say here, because here's a case, right? Okay, so because here they want to find it's a k, that's fine. So the coefficient for the y to the k. All right, so coefficient to the y to the k from this binomial expansion. What is the coefficient y to the k? By the binomial expansion, I know it's what is m plus n to the what? K's power. Correct? Okay. Now, let's take a look at 1 plus y to the n's, right? So 1 plus y. Okay, so this is 1 plus y to the m's power, and this is 1 plus n y to the n's power. Okay, so now I'm going to expand that, right? So I'm going to expand this one. I'm going to expand these ones here, right? Okay, so 1 plus y to the n power, right? So it's kind of like by using combinations of what here I have n to take 0, then the y to the 0 power plus n take 1, and the y to the first power, because the x here is 1. So that's why I choose the x equal to 1. So, or you can say this is 1 and 1 to the n minus 1, but it's 1, so I cancel that. So like m to the 2, so this is y to the square, to the n to the n to the y to the n's, right? Okay, so this is the first expansions, right? So that's why if you use this is what I've expanded like here. Now the 1 plus y to the n's power is the same thing. So first is n0, then plus n1, y1, plus n2, y2, then plus n to the n, y to the n. All right. Okay, so this is my second expansion here, right? Okay, so think about it. I am looking, right? So I'm looking for what? I'm looking for the y to the k's powers, right? Okay, so now let's take a look. I'm looking for y to the k's power. Okay, so for the first ones here, right? So when you do this, like, if you FOIL this, right? So let's take a look at the first items here. So, okay, so for these ones here, m to the 0, this is y to the 0 powers, right? Okay, so in order to get a y's power, so when I FOIL this, what is the only one I can get? So this is m to the 0, right? So the only one will give me y to the k. It will be n to the k, y to the k's power, correct? Okay, so now if it's still not clear, let's take a look at these ones here, right? So for these ones here, all right, so these ones here, when this one try to FOIL it, so it's n1, 1 to the first power. So this is the m1, y to the first power. In order to get a k, what type of the things here I need to get? What type of the terms in here I need to get? I have to get a y equal to what? K minus 1s, right? In order to get a k. So what is the coefficient in front of these ones here? It will be what? N to the what? N to the k. That's right. Okay, so let's take a look at one more. So now all the others, so when you try to FOIL this, right? So when you try to FOIL this to all the terms here, right? Only one term will meet the requirement. So let's take a look at the other ones here, the third ones here, right? So these ones here, m to the 2, y to the squares, right? So for these ones here, this is m to the 2, y to the square. So when I try to FOIL it, right? So I try to FOIL times every term in the second bracket. I only can find one is y to the what? K minus 2, right? Because the k minus 2 to the 2 will become y to the k's, right? So will give me the y to the k's power. So what is the coefficient in front of these ones here? These ones will be what? N to the what? So this is sorry here. I did not be careful here. This will be okay. So this is a k minus 1s, right? So the same here. This is a k minus 2, and the dot 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 dot. Okay. So now let's take a look, right? So let's take a look. So if the n, I have a k's powers here. Okay. So if n have a k's power, so then this will be yk, right? So then what is the only term I have to match that? I have y to the 0 power to the orange bracket, right? So what is the constant here? So this is n0s here. Did you see here? Okay, so that's why all this, right? So if you take a look here, this one, this one, this one, this one. So they all give you y to the k's. So that's why I can write it. I will say summation r from 0 to k's, right? So I start with n, r equal to 0, right? So when r equal to 0, what is n? N has to be what? K minus, so k minus r's, right? So here, yeah, so this one's here is r, right? So when r equal to 0, so if you say here, so all this, right, will give you the coefficient of the y to the k. That's how do we prove here? So summation r equal to 0 to k. This is mr, n, the k minus r is equal to m plus n to the k's here. All right, so that's very interesting, the proof, and we use the binomial coefficients here. And you know that if you go to some mathematical statistic book, they're going to have some other proof problem, very interesting problem, and you can show the proof. And so in here, I just want to give you some introductions, how to prove those equations. Like I say, if you are only in the introduction statistic course, you might not be able to, you know, you don't need to, you know, kind of, you can skip this video. You don't need to know how to prove it. But if you are in the higher class, like for the mathematical statistic, and then you might want to get familiar with those skills, how do you prove it? Okay, so that's it. That is for this video. I hope you enjoyed it, and I hope you learn a little bit of skill how to prove the things in statistics. And so if you like the video, and don't forget to subscribe it. And if you have questions, leave me a comment, and I will answer your comments here. Okay, so it's nice to talk to you, and hope to talk to you again in our next unit. We're going to start to talk about the simple space and events, those things. Those are the fun things also. Okay, so let's, you know, that's it for this video, and have a good day. Bye.